At what point or points is the tangent line for g of x equals the square root of 2x squared plus 4x parallel to the line y equals 3/2 x plus 5? Parallel lines have the same slope. The slope of y equals 3/2 x plus 5, y equals mx plus b, m being whatever is in front of x, the coefficient of x. 3/2 x plus 5 has a slope of 3/2. Our tangent line has a slope that is the derivative. So we're going to find the derivative of g of x. G of x is the square root of 2x squared plus 4x. I'm going to rewrite that as 2x squared plus 4x to the first power second root 1/2 power for the derivative. The derivative, g prime of x, will be bring down the power, 1/2, leave the inside alone, 2x squared plus 4x, subtract 1 from the power, so 1/2 minus, I will call it 2/2, and then multiply by the derivative of the inside to complete the chain rule, 4x plus 4. So I have 1/2, I have a 2x squared plus 4x that'll now be to the 1 minus 2 negative 1/2. And then I have that 4x plus 4, which has a common factor of 4. It may be a good idea to factor that out. And it's 4 times x plus 1. So my g prime of x now will be, well, I can put the 4 and the 1/2 together. I have a 1/2 here and I have a 4 here. 4 times 1/2 is a 2. So I will have a 2. I still have that x plus 1 left over. And I have that quantity to a negative exponent. This here I'm going to put in the denominator as a positive exponent. So 2x squared plus 4x will now be to the positive 1/2. We can rewrite that as the square root to the first power, so it'll be the square root of 2x squared plus 4x. There is our derivative and our slope of the tangent line at any x value. We need this to be parallel to the line that was given. Parallel lines have the same slope. We're going to want this to have a slope also of 3/2. There's what we need to solve. Looks a little messy at first, but we can cross multiply. Let's bring this 2 up with this on that side, and this square root of 2x squared plus 4x, let's take that up with that 3. That's the cross multiplication. 2 times 2 is a 4, so I will have a 4 times the x plus 1, and then 3 times that square root. The 3 is not inside the square root, so I'll just leave it outside here, and then square root of 2x squared plus 4x. We're trying to solve for x here, and therefore we now need to square both sides so that I can take the root, square, it will remove the root so I can have the x's outside of the root. Now this side squared, 4 squared is a 16, x plus 1 squared, and over here 3 squared is a 9, and then the square root squared cancel each other out, and I will just have the 2x squared plus 4x. That x plus 1 squared, I am going to need to FOIL that out because I have an x squared and x term on the right side, and we have to combine like terms together. So let's write that as x plus 1 times another x plus 1. On this side, I'm going to distribute the 9, and I will have a 18x squared plus a 36x. Foiling out x plus 1 times x plus 1 first, x squared. Outside 1x, inside 1x, we'll just combine those and just say 2x, and then last 1 times 1 is going to be a 1. Let's now distribute the 16 in. So 16x squared plus 32x plus 16 equals to 18x squared plus 36x. Let's bring all the terms to one side. I will subtract them all to the right side. 18x squared minus 16x squared will be a 2x squared. 36x minus a 32x will be a positive 4x, and then we will bring the 16 over, which will be a negative 16. And that way I keep my x squared term positive. So we've turned this into a trinomial quadratic equated to 0. We now are going to be able to factor that trinomial quadratic. We can start by factoring a 2 out. It does have a common factor of 2, and that will leave x squared plus 2x minus 8. And now we can trinomial factor. We need two numbers to multiply to give us negative 8 and add to be a positive 2. So that would be a positive 4 and a negative 2. And it looks like we have an x-coordinate of negative 4 and positive 2. Those are our x-coordinates for the points. We now need the corresponding y-coordinates. So let's start with x equals negative 4. The corresponding y-coordinate is found by plugging that x-coordinate into the function g of x. Make sure to use the original function g of x, not the derivative. G of x gives you the y-coordinates. So we want g of negative 4, which means we will have the square root of 2 times negative 4 squared plus 4 times negative 4. So we will have the square root of 2 times negative 4 squared is 16. And then 4 times a negative 4 is a negative 16. Two times 16 is a 32, and then minus the 16. So we end up with the square root of 16, which is a 4. We have an x-coordinate of negative 4, and we have a corresponding y-coordinate of positive 4. Now we have that other x-coordinate of 2. The corresponding y-coordinate will be g of 2, which will be the square root of 2 times 2 squared plus 4 times 2. Two times 2 squared is a 4. 4 times 2 is an 8. So we have the square root of 2 times 4 is an 8, plus the other 8. 8 plus 8 is 16. Square root of 16 is a 4. And we get the other point to be an x-coordinate of 2 and a y-coordinate of 4. So we have 2 points where the tangent line for g of x is parallel to the line 3/2 x plus 5.